Dear student, today we will see one of the important concept in case of decision making, that is job sequencing. Because for any decision makers, they have to properly schedule all resources so that the total idle time of that resource will be minimum. So because if the idle time is more, that is the indirect loss of that particular organization. So to minimize the loss, you have to properly schedule all assets, that may be a man, that may be a machine, that may be a material, in a proper way so that there will be very minimum idle time, we can say, and you can utilize the resources effectively and efficiently. Today we see one method to process n jobs on single machine using earliest due date method. So before starting in or solving any example on EDD method, we'll know some basic terminologies which are needed to be known for solving the job sequencing problem. So the first terminology is you have to job numbers. So what is job number? Job number is nothing but numbers of machines. That is number of machines. Number of machines are nothing but the given jobs you have to process on how many machines. There are single server or there are multiple server. There is a single machine or multiple machines. So that is nothing but number of machines. Processing time nothing but to complete the single job, what amount of time, that may be minute, that may be days, that may be any unit, the time required to complete the all process of a single job. Third one is a processing order. Processing order is nothing but in what sequence we are processing the jobs. So you have to process the job on first machine, then on second machine, then on third machine. So that is nothing but a sequence, processing order. So in what sequence we have to process the job. Third one, next one is a idle time. Idle time is nothing but free time for the machines. If any machines wait for a job, then that waiting time is called as idle time for that particular machine. And last one is the elapsed time. Elapsed time is nothing but when you start a first job and the time required to complete the last job, the time elapsed between these two processes means total time to start the first job and time required to finish last job. That total span of time is called as elapsed time. So if you are very much aware about this terminology, then it is very easy for us to solve the job sequencing problems. Now, so we'll see some basic assumptions that you have to be considered while solving the job sequencing problem. The first assumption is that only one operation is carried out on a machine at a particular time. Means a single machine is dedicated to perform only one task or only one job at a time. This is first assumption. Means a single machine cannot process two or more activities at the same time. It is only one activity should be processed by the machine. Each operations once started must be completed. When you assign any job to any machine, till that job is completed, you cannot remove that job, or till that job completes, you cannot assign new job to that particular machine. And third one, an operation must be complete before succeeding operations can be started. Means what operations you have assigned to machine, you have to wait till that operation gets complete. When the operation gets complete, then next job will be processed for that particular machine. These are some assumptions related to job sequencing you have to take into consideration. Now we'll see one simple example for job sequencing for the case earliest due date. So processing a job on one machine using EDD method. EDD is nothing but earliest due date method. The table given to us contains information about 4 jobs that are waiting for machine. So job names are given here. Jobs are A, B, C, D. These are the jobs. Their respective processing times required to complete the particular job in days are 14 days, 10 days, 7 days, and 6 days. Due date is that job A you have to return back within 20 days. Job B was within 60 days. Job C 50 days, and job D 70 days. So what is the time required is given here. What is the time duration within which you have to complete the jobs and send back to the members from where you have received the jobs for your processing purpose. So what are the different activities they have asked? Obtain, determine optimum sequence as per due date method. You have to calculate optimal sequence. What is the proper sequence? Optimal sequence is nothing but proper sequence which requires minimum idle time, or it will the efficiency of machine will be maximum, and that you have to calculate using earliest due date method. Here we have to assume arrival sequence in A, B, C, D. Means first A machine here to is arrived, then B machine is arrived, C and D. These are the arriving sequence of machine in your, we can say, repair center. Okay. Average lateness. How much maximum average late the machines will get, the jobs will get. Average number of jobs at workstation and average job flow time. So these four things are asked. So we will solve this example. First, you have to identify the optimum sequence. And for that purpose, we have to use Johnson's method. So what is that? They have given jobs, their processing time, due dates are given. As per the earliest due date method, job sequencing will be, you have to create one table, sequence and jobs. Now we have to identify which job we have to process first. So earliest due date method, what it says, you have to process the jobs which is having minimum, or we can say shortest due date. So in the given due dates, the due date is for the minimum due date is 15, which is related to machine C. So machine C you have to process first. Then less due date is for machine B. Then machine D and last machine A. So by considering the due dates, we have created the job sequence. From the job sequence, what we understood, you have to process first job C, then job B, job D and job A. In this fashion, you have to complete all jobs. Then we have to calculate the flow time, late and waiting times, all those things. So this is given in our example. So we have identified the proper optimum job sequence. First you have to process job C, then job B, job D and job A. For job C, what is average processing time required? This processing time that is as given in our example. We have to just write that C requires 7 days, B requires 10 days, D requires 6 days and A requires 14 days. Likewise, what is the due date is also given. For C job, 50 days is the due date. For job B, 60 days is the due date. Job D, 70 days and job A, 20 days. Then we are calculating the flow time. Flow time is nothing but how much time this job C will require. So job C will be complete after 7 days. Then when job B will be complete, job B will start after 7 days and it takes 10 days. So 7 plus 10 is 70 days it will take. For job D will start after 70 days and it takes 6 days. So 17 plus 6 is nothing but 23. And likewise, job A will start after 23 days and it will take 40 days. 14 days, sorry. So it will be 23 plus 14 is 37. Okay. Now we have to calculate late days. So job C due date was 50 days, but we have completed that within 7 days. So this job is not delayed. So delayed is nothing but 0 here. Job B was expected to submit at date within day 16. But to complete the job B, we need 70 days. So 1 day job B will get delayed. Job C is expected to be complete within 70 days, but it requires to complete 23 days. So difference between these two is nothing but late days. Likewise, job A will be late for 70 days. So when job C is processing, so how many jobs are waiting? Three jobs are waiting and this is under process. So total 4 jobs are waiting. Likewise, when job B is processing, 3 jobs were under queue. Job D is processing, two jobs are under queue and job A is under processing. So one job, that is current job, is waiting for that particular service. So we have prepared the table. Then from this table we can easily identify the total elapsed time or total completion time to finish all jobs is nothing but 37 days. So we need 37 days to complete all jobs. Average job flow time. Average job flow time can be calculated by doing addition of all due dates, sorry, all flow times divided by number of jobs. So what is average flow time? Flow time? Flow time is given here. We have to do the addition of all flow times. 7 plus 17 plus 23 plus 37 divided by number of jobs. There are 4 number of jobs. So if you solve this example, you will get time required. Average job flow time is equal to 21 days. Then average lateness is equal to how many days though you have to, you will all jobs will be total average late you have to send. So for that we have to do the addition of all late days. So 0 plus 1 plus 6 plus 17 whole divided by how many jobs are there? 4 jobs. So whole divided by 4, you will get 6 days. On an average, it is observed that 6 days will be the lateness time. And average number of jobs at workstation can be calculated by the formula processing time into waiting time for the job plus second jobs processing time plus how many jobs waiting at the time, in this fashion. So the formula, when you put the values of that, you will get 7 into 4 plus 10 into 3 plus 6 into 2 plus 14 into 1 whole divided by, you have to divide the whole values with the total processing time, that is 7 plus 10 plus 6 plus 14. So if you solve this expression, you will get average number of jobs at workstation will be 2.27. So in this question, you can solve any job sequencing problem using earliest due date method. So if you have any doubts regarding this, you can call me. My contact number is 98500 and my name is Dr.B.J.Mohite. So I will stop here. Thank you.